Okay, good morning. Assalamualaikum. Today I will continue on the previous example, example 1 and example 2. Okay, we'll try to do using solver. Okay, we go through again for example 1. Yesterday we did on the manual plotting. Okay, by identifying what is the decision variables, objective function, and also defining the constraint. Okay, whether it is equal or inequality. Objective function is the important part. Okay, then identify a constraint. So from example 1 yesterday, we have 2 inequality constraints. Sorry, 3, yeah. Inequality constraint where it is related to the nitrogen and phosphate content. Okay, and then both bags should not be negative. Okay, so yesterday we had done on the graph over here. So, okay, any question before I move to the solver for the graph here? Can I? Plot it according to the constraint equation. Then you will find your points, the feasibility points. Okay. Now I want to move to solver. Okay, now for this one is based on example 1. Okay, example 1, we have the infos, the nitrogen. Okay, where's the profit? Okay, this is how I sort the table, all the infos, where our decision variables x1 and x2. Okay, x1 is supergrow, crop quick is x2. Now, based on the table from the question, it listed out the nitrogen and the phosphate content, each of the bag. Okay, I just put it in table form. Supergrow, nitrogen and phosphate, crop quick, and the cost. Okay, so this is the requirement. Nitrogen must be more or similar to 16. Okay, phosphate 24 and above. Now the question asks you to find. The question asks you to find how many bags of each brand to minimize the total cost. Okay, how many bags? Okay, so that's why here I put number of bag, our unknown. Okay, number of bag. Then from the number of bag, how much of nitrogen and phosphate? Okay, this is how I link. This is the number of bag, the one that we want to find out. This is the total amount of nitrogen and phosphate from the number of bag. Okay, look at the link to this cell. Okay, how I link. We must link the cell so that later on we can use the solver. How to set the solver. Okay, the total for nitrogen, crop quick, okay, E6, where is 6? Number of bag multiply with the nitrogen content plus E7, number of bag of the crop quick multiply with nitrogen content. Okay, now this one we focus on the nitrogen content only. Okay, this cell, nitrogen content. This cell, we focus on the phosphate content. Okay. Now this is to set up the table first. Then our objective function. Objective function, this is the equation of our objective function, which it requires how many bags of crop quick and super grow, X1 and X2, to minimize the cost. Okay, so how I set? 6, according to this equation, 6, okay, 6 here, I take as the cell. You can also put the number, but later if you just link it with the cell, if you change the number in the cell, everything will be changed. Okay, so here I link with the cell of the cost, multiply with the E6. E6 is number of the bag of the super grow. Okay, plus 3. 3 is cost of the phosphate. Multiply by X2. X2 is the crop quick. Okay, this is the equation for the objective function. Up to there, can? You want to try to set up your Excel first? You have Excel in your tab, in your laptop? Okay, I want to teach you how to use the solver because it will be more easier to find out your objective function. The green box, the green cell is the link. This is the one that we varies. Okay, number of bag. This one linked to the number of bag. Okay, how to see it linked? Yeah, this is how they link. This cell. Okay. Okay, we start with 0 bag. So everything will be 0. Set up the equation for your objective function also. So this is how they link up for each cell. Okay. Then, okay, make sure you set up the objective function cell link up with the infos over here. Now we have the constraint, phosphate constraint, and also the nitrogen constraint. Okay, we have 3 constraints over here. Now, do you have solver in your Excel? This data solver. Okay. If you don't have, you have to add in. Got solver in your laptop? Okay. Now, click for solver. This one I remove first. Reset. Yeah, solver. So set objective. Set objective here is our objective function. So our objective function is this cell. H in my Excel, it would be this cell, column H. So click on the cell. Okay, just click on the cell, our objective function. Now what we want to do? To what? Max, min, or any value of min. Okay, our objective function is to minimize the cost. So click for min. You can use solver even though for the max and the value of. Let's say you want to find your objective function, you have one set integer. Let's say you want to find the value of 5. Objective function you must be 5. So you can set value of, then you type in the number. Okay, let's say in your FYP or PDP, you want to find SSE, the error, square root error, the minimum number of error. So you click min, the minimum, or you want to just set it value of 0. You don't want any error. So value 0. Okay. Then, okay, here min, by changing variable cells. Which cell that we will change? So our changing variables will be the x1, x2, right? The back, number of the back of x1, x2. So this is the variable cell. This one I just drag. Or if you have separate cells, just click the cell. Okay, I repeat. Variable cells, the one that we will manipulate. The decision variables. From the objective function, decision variables is the x1 and x2, which x1, x2 is the number of back of the brand. Okay, so here, changing variables is the number of the back. Want to identify how many backs. Okay, now we have constraint, 3 constraints. to see. Okay, add. Wait. Add your constraint. Okay, first constraint. Phosphate constraint. Okay, we put as phosphate constraint. Now, cell reference. What is your cell reference? Phosphate constraint must be more than 24. Here. Okay, total of phosphate must be more than 24. This cell, the total of phosphate. Okay, this cell, D10. Click on the cell. Phosphate constraint, more than 24. More or equal to 24. So we choose this one. Okay, so the constraint is more than 24. Click on the requirement. You can directly click, you can directly key in 24. Also can. Okay. Can, so we add this constraint. Now we have another constraint, which is the nitrogen constraint. So our cell reference will be the total of nitrogen. That should be equal or larger than the constraint is the requirement, which is 16. Okay, then add. Another constraint. This one must not be negative. So, sorry. Okay, cells reference. Supergroup X1 must be larger than 0. Okay, add. Then X2 again must be larger than 0. Okay. Okay, then go back to this. We have now 4 constraints added. Okay, after that. Now here, tick this. Variables non-negative. Solving method, simplex. Linear programming. Okay, simplex linear programming, LP. Okay, then solve. Okay, it mentions solver found a solution. So all constraint and optimality conditions are satisfied. Okay, then you get your value, 24. Number of bag here, it already counted for you. Okay, so all of your nitrogen phosphate composition in each bag, the total, we have it here. Okay. Any question? Okay, I go again. Objective is your objective function, set objective, your objective function. What is your purpose? Max, min, or value of. Here we want minimum. So we click on the minimum. Changing variable cells. This is the cell that we want to change. We want to identify how many bags to achieve our objective. Okay, then add all constraints from the constraints provided over here. Phosphate content must be more than 24. Nitrogen content must be more than 16. And X1, X2 must be more than 0. Cannot be negative. Okay, select for simplex LP, then solve the problem. Okay, here you can put any number first before you run. Just now I put 0, 0. Perhaps you can put 1, 1. Okay, because we do not know. So run again the solver. Do it the same. Changing cell, the same. Sorry. Objective function is here. Okay, so changing variable cells is here. These two. Okay, with the same constraint, solve. We still give you the same number. Okay, let's see if we want it as the max, whether it is feasible. Okay, with the same objective function, cell, same variable cells, and with the same constraint. Okay, try to solve. Okay, here you see, objective cell values do not converge. Solver can make the objective cell as large as it wants because you don't have any range, okay, any stopping point. Try. Cannot because you don't have the stopping value. It can go as maximum as it can go. So that's why it appeared that that thing. Okay, let's say we set the value of for example, you want your cost just to be $35. So how many bags that we need? The same constraint, the same variable cells. Okay, then we try to solve. Still have, okay, now have a solution. Okay, now, okay, your objective function just now we set as 35. So it meet the 35. Now it gives you the number of bags that you requires to meet all the constraints with the cost of 35. Okay, so it meets all the constraints. Okay, yeah. Now let's say, is it feasible if we put just now 24, 10? Okay, so here it cannot solve. Solver could not find a feasible solution. Not feasible because it doesn't meet the constraint over here. Phosphate content 10 only, which doesn't meet the constraint. Nitrogen 13 doesn't meet the constraint. So that's why it pop up, cannot find the solution. Okay. Okay, this is our minimum. Okay, I give you 5 minutes just to play around with your solver before we move to the next example. you need to know how to set up your table. What is your decision variables? How to put up the table, okay? And link them. For those who are doing absorption for your FYP, right? Absorption, column absorption, you can use solver to find your model, kinetic model. Not that hard, easy. You can use solver because for absorption columns, you have a lot of data. Okay, so from there, you can use solver to find out your kinetic models so that it meets the criteria of R2, R square approaching 1. You can set that, R square approaching 1. Okay, so you can use solver in your PDP and FYP to find out the what is the correct value. Okay, now we move to example 2. Example 2 have a lot more constraint to consider. Okay, this is from example 2. You should try on your own because to come up with this table, it takes time. How to arrange your data and how to arrange your the link cell. Now, this is the data that I extract from the example. Okay, this is our example yesterday. Okay, the M1, M2, and also the profit value. Now, our decision variables is the exterior and the interior. Cut short of it. Okay, the maximum daily availability already mentioned over here, 24 and 6. I just plug in into the table over here. Okay, profit. Now, our constraint, our objective function is to find the maximum total daily profit according to how many number of X1 and X2. Okay, that's why I put here the total. Sorry. So I already run. Okay. Now, how many number? 0. This is our decision variables. How many number of X1 and X2? Yeah. Okay. We want to find how many x1 and x2 required so that you can have maximum total daily profit. Set your objective function. Okay, link up to the x1 and x2. This is how I link them. 5 here is the cost, sorry, the profit. Okay, 5 multiplied by x1 number. Okay, this cell, the number of x1 plus 4. 4 is the profit for x2. Over here, multiply with number of x2. Okay, then set your constraint equation. Now we have a few constraints over here. We have M1 constraint, which it must be less than 24. Okay, here I set up the constraint equation according to the equation over here. Why I put a cell for the constraint equation and market limit? Because later on it will be easier to set up the constraint in the solver. Okay, that one constraint for M1, and we also have constraint for M2. Okay, it relates with the M2, amount of M2, and also the number. Okay, then we have constraint for the market limit. Market limit. Okay, market limit, x2 minus x1 must be less than 1. Okay, demand limit, later we can just add in the solver. Okay, because it doesn't require any equation over here. Okay, then we move to solver. Okay, our objective function, set objective. Click on the cell. Now what we want to do, max, min, or value? Max. Click on the max. Okay, our requirement is to find the maximum profit. Now changing variables is our decision variables, which is this cell. We want to know how many interior and exterior paint that is required to maximize the profit. Okay. Then add the constraint. We have a few of constraint over here. Now, constraint, M1 constraint. We go one by one. Huh? Cell reference, click here. Okay, so that's why I create a cell for the constraint M1. M1 constraint must be less or equal to 24. So less or equal 24. You can straight away type in 24 or put in the cell. Okay, then add another constraint, M2. Here. M2. Then the sign will be less or equal. Same sign. 6. Okay, M2 constraint, 6. Click on the cell. Click on the cell, or you can straight away type in 6. Okay, add. Next constraint will be the market limit. Click on the limit, market limit cell. Market limit must be less or similar to 1. Okay, choose the correct sign. Constraint here, 1. So just type in 1. Okay, add. Another constraint would be the demand limit. Okay, demand limit over here only involve X2. X2. Which cell to click? Demand limit X2. This limit. Which cell to click? D. Okay, let's see. Here, D10. Okay. Here, X2 for the demand limit. Then the sign less or equal 2. Just type in 2. Okay, add. Any more constraint? Any more constraint? No more. Okay, no more. Cancel. We go back to this. Okay, choose simplex LP. Simplex LP, linear. If your model is non-linear, then you choose the non-linear. GRG non-linear. Here we choose linear, simplex LP, because we are focusing on the linear programming. Okay. If your model is non-linear, but you choose simplex linear, your answer will not be accurate. Okay. Now then solve. It found a solution. Click OK. Market limit -1. How do you set? Wait. It's my market limit X2. X2 D10. Wait, I think mine is X1 minus X2. C2, sorry, X2 is this minus X1. Sorry. Negative. Okay, now check back. We try again. Check back on the constraint. Constraint is which one? Yes. Market limit negative 1.5. Objective function is 21. So your maximum profit is 21. Okay, then this is the exact number for X1 and X2 to achieve your maximum daily profit. Okay, now it is similar to your slide. Yesterday's slide. Here. Okay, yesterday we did it graphically. This is the maximum calculated. Okay, graphically. When you use solver, we can get the same value. Market limit, it made the constraint. It must be less than 1. Because from the statement, daily demand for interior paint cannot exceed for that exterior paint by more than 1 ton. So here, why we set this kind of equation? Because we do not want X2, sorry, X2 interior paint more than exterior paint. Okay, that's why we set this equation. X1 interior, X2 interior is X2. Is it? X2. X2 cannot exceed X1 by more than 1 ton. So it must be less than 1. That's why we come out with this equation. Okay, or let's see if we set this equal to 1. Gee. This one. This is the market limit. Let's say we set as equal to 1. Okay. Okay, equal. Let's see how is the result. Objective function will be different. Okay. So that's why it is important for you to come up with the constraint equation over here, according to the statement. Okay, 5 minutes just to play around with your solver. how if we want to set the daily profit? Let's say we want to set up to $50 with the same constraint. Will it work? Okay, cannot. No feasible solution because all constraints cannot be satisfied. The constraint is extended. Constraint extended. What is my question?
Yeah, so probably this wheel is because I didn't know it's
Okay, I wanted to highlight again on the feasibility region. Okay, I want to highlight again on the feasibility region. Now wait, let me open the notes similar to yours. Wait. Still not the same. I haven't updated. I will update by this week. Saturday, 6 April. Haven't finalized yet. Yeah. I think 15 minutes. I don't remember. I will upload once all the details once finalized. Huh? I'll try by this week. Okay, so I want just to re-highlight again on this example, since some of you still confused on the constraint. Okay, this is similar to your notes. Perhaps I use the different version of the notes. Okay, now in these notes, you have two more constraints. Okay, you have two more constraints. You have x1 and x2 must be more than 0. Okay, now I want to highlight on the feasibility region. Feasibility region. What does it mean by feasibility region? After you plot according to the constraint, okay, after you plot everything according to the constraint, you will have this region. Okay, this is your feasibility region. So any point in here will meet your constraint. Any point in here will meet your constraint. Okay, but the objective function that we want to find is the maximum daily profit. Okay, according to this example, when you do it manually, calculated, you will find this is your maximum daily profit. which it falls at this point. Okay, max. Now, I want to go through each constraint, the line for each constraint. This is the constraint for M1. Okay, M1. Constraint for M1. So, you plot the line, you will get this. Okay, this line. This is the constraint for M2. Plot the line, so you will get this. Okay, number 2 over here, this line. Constraint number 3, which is the market limit, you will get this. Okay, this one, number 3. Constraint number 4, which is demand limit. Okay, demand limit. X2 must be lesser than 2. Demand limit X2. Here, number 4. Less than 2. So that's why the feasibility region is going down below the 2. Okay, now these 5 and 6 constraint. Why it is necessary to set the limit of this constraint? X1 and X2. Why it is necessary to set this constraint? Correct. You cannot produce negative value of pain. Means you either have it or don't have it. 1 or 0. It cannot be negative. Okay, that's why we put this 5 and 6 constraint. If you don't put the constraint, your feasibility region can go down. Okay, if you don't set 5 and 6 constraint, your feasibility region can go up to the negative value. When you set must be larger than 0, equal or larger than 0, so you close the boundary at this point only, at the x-axis. Okay, at this boundary only. Five, 6 constraint is to close the boundary, and as in real practice, there is no negative value. Okay, so the highlighted area is your feasibility region. Okay, this is your feasibility region. Any point inside that feasibility region meet your constraint. Okay, the previous example, the feasibility region, example 1. The feasibility region okay, this is the point that made the requirement yesterday. We had proved it from the equation. So your feasibility region for this example would be up here. Okay, all the way moving upward. That is your feasibility region. That's why the objective function here is set as minimum cost. If you go maximum, you can have any number, infinity, because you don't have the boundary. Okay. Can I? Any question? I'm not going to start on the simplex method yet because it requires one full lecture. Okay, so today, the remaining time, I want to discuss with you on the project. I have drafted the project. Okay, listen. I have drafted the project to accommodate to your PDP.